We are going to continue with section 2.2 today. And this section of 2.2 is pretty detailed. So we're going to look at how to find percentages if we're not exactly 1, 2, or 3 standard deviations away from the mean. And there are a couple of ways you can do that. So we'll see all of those today. One of them is using your graphing calculator. So if you have a calculator and it's not with you, you might want to pause the video and go grab that. Okay, so we talked about standard normal distribution yesterday, normal distribution yesterday. So today we're going to talk about standardizing, so specifically putting things on the same scale. So something is considered the standard normal distribution if its mean is 0 and standard deviation is 1. So down here we have that notation, normal distribution, mean 0, standard deviation of 1. Any variable that has a normal distribution with any mean and any standard deviation can be standardized, and we can find its standardized value using this z-score formula. This tells us exactly how many standard deviations above or below the mean a particular value falls, because we take their score minus the mean, so that gives us how far away, divided by the standard deviation, so how many standard deviations away from the mean. So with the empirical rule, if we were 1, 2, or 3 standard deviations away, we could estimate the area under the curve. Now we're going to see how we can do that for any number of standard deviations away from the mean. So here we have that standard normal distribution. You can see here centered at 0, and then just 1, 2, 3 because standard deviation is 1. -1, -2, -3, again, because that standard deviation is 1. So we can describe the standard normal distribution with a table, and this is called Table A. And so Table A is in the back of your textbook. It's one of the appendix options that you have. Table A is also available in the formula packet for the AP exam, so I'll be showing you that in just a few minutes. So basically, Table A gives you areas under the standard normal curve. The key is that it's the area under the curve to the left of Z. So if we want to find the proportion of individuals that are less than a certain value, we can standardize and then go straight to Table A. If we want to find more than a certain value, we have to first find the area less than and then subtract from 1 or subtract from 100%. So here, we're going to take a look at an example where we already have a z-score. We want to find the proportion of observations from the standard normal distribution that are less than 0.81. This is our z. So this is just a snippet of Table A. The way Table A works is it gives you the 1s and the 10th digit of z on the left, the 100th digit across the top. We have to find where they intersect to make 0.81. So we go to the 0.8 row, we go to the 0.01 column, and that then gives us the area to the left of Z in that cell. So there's your 0.8, 0.01. The area to the left of that z-score is 0.7910. So essentially this is telling us that 79.1% of the distribution lies to the left of 0.81. This is notation that you should be using. The capital P is really for probability, and we'll get into that probability notation in chapter 5. But we're talking about the probability, or you can think of it as the proportion of z-scores less than 0.81 if you want to think of it that way. So we can also use the standard normal table to find proportions that are between two values. So here you have a z-score of -1.25, a z-score of 0.81. It always helps to sketch your curve. So here is one normal curve. We already found that 0.81 on the previous slide. That area was the 0.7910. But then we also have the z-score of -1.25. We only want what's in between. So we're going to have to subtract that area off. So we also have to look up the area to the left of -1.25 using the table, which if we were to look up -1.2, where it intersects with 0.05 for -1.25, that area to the left is this 0.1056 that we see in the box here. So that difference gives us the area in between. so 0.6854. So here's just another way of finding the same information. You can think about the fact that the whole distribution is equal to 100% or equal to 1. So here they're showing you the area to the left of negative 1.25, which is this 0.1056, which we already had up here. You can find the area to the right of 0.81, which is really just the 1 minus 0.7910 to get this value here. So we can do 1 minus these exterior areas. So 1 minus 0.1056 plus 0.2090 to get that same value of 0.6854. So when we do normal distribution calculations, we're really going to start to build the 4-step process here. So still, we want to restate the problem, and we can do that in a sentence. We want to do it in terms of the observed variable x, because in the last couple of slides, you already had the z-score and just found the area under the curve, which is not really all that realistic. What we're going to ultimately see is IQ scores follow a normal distribution with a given mean and standard deviation. What's the probability that the IQ score is greater than 112? Or what's the probability that the IQ score is less than 92? So you have the x value. That's what you're trying to answer the question about, but then you're going to have to standardize. So your plan is going to be to draw a picture of the distribution and shade the area of interest under the curve. And then you're going to perform your calculations. So you'll find a z-score, and once you have a z-score, you're going to use table A or the calculator. I'll show you the calculator here in just a few minutes. And then you're going to conclude in the context of the problem. So you would say the probability that the IQ score is greater than 112 is equal to whatever answer you found in the do step. So here's an example that deals with an x value. So here they're talking about Tiger Woods. It says that his balls travel with a normal distribution, mean of 304, standard deviation of 8. And we want to figure out what percent of his drives travel between 305 and 325. So that's really our state step. Just restating that question in terms of x. For the plan, we draw a picture. So here's the normal curve. We put his mean in the middle. These are our multiples of standard deviation. We shade in the region of interest, so 305 to 325. This not only helps us use table A, but it also helps us see if our answer just doesn't make sense. Maybe we made some sort of mathematical area. We can kind of see at least this is going to be less than 50%. If we come up with an answer that exceeds that, something definitely went wrong and we need to go back and check our work. So then we need to standardize. And so because we're between two distances, we need two z-scores. So the 305, it's always observation minus the mean over standard deviation. And again, watch that order of operations, either parentheses or two separate steps. We also need a z-score for 325. So 325 minus 304 over 8. So we then want the probability that it's between those two values. So here's our do step. You don't have to show these three curves here. This is just showing us how to find what's in between here. But essentially what you're doing with table A is that you look up that z-score of 2.63, and that gives you everything to the left. But we don't want everything to the left because we only want what's in between here. So we've got to get rid of this area. So we need to look up the area to the left of 0.13. And then we subtract them. So this giant area minus what we're not interested in gives us what's left in between. So here we can find the area to the left of 0.13 using the z-score or table A, and to the left of the 2.63. So if we use table A here for the 2.63, 2.6, 0.03 on the top, they intersect at 0.9957. That's where this number is coming from here. Looking at the 0.13, if we find 0.1, where it intersects with 0.03, That's the 0.5517 here. So the difference between them gives us the 0.4440. So about 44% of his drives travel between 305 and 325 yards. So this is your conclude. In terms of the notation that I mentioned that you should be using, you kind of have two options in terms of how you would write this. We could say the probability that the x value is between 305 and 325. So 305 is less than x is less than 325 is equal to 0.4440. Or we can write it in terms of the z-score. So the probability that 0.13 is less than z is less than 2.63 would also be equal to that 0.4440. So that's kind of the end of your do step. Somewhere you should have that notation. And that's something that the first couple of times you do it, I won't take off points if your notation is incorrect, but I will comment on it because I really do want you to get it right. That's something that's really going to set your response apart from the rest on the AP exam if you use that notation correctly. So because of that, like I said, at first, you will have a little bit of flexibility. If you maybe accidentally put your inequality sign the wrong way or you put a Z instead of an X, that'll be okay at first so you can get some feedback and really get comfortable using that probability notation. Okay, so here's the assignment here, if you guys want to take a minute to write that down. And then I do want to show you the table A in its entirety, and then I also want to show you the graphing calculator. Okay, so here is the formula packet for the AP exam. So it is many pages. Like I said, you will be able to use this on tests and quizzes in the classroom, and it's the same set that you would get provided to you on the AP exam so that you're comfortable with it. Some of these things we've already seen in class. Like we saw the formula for standard deviation. We saw the formula for mean. We will learn about the rest of those as we go through. We've got some other rules that we'll learn about this year, but if we keep scrolling through, you get to the section where it's tables for AP stats. The first table is Table A. And I do want to mention a couple of things about Table A. Table A is separated into 2 pages, and you have both negative and positive values for Z. So all the negative Z scores come first, and then it's kind of split over 2 pages. Then you've got your positive Z scores on the next page here. Some students always question, why do we have a positive Z or positive 0? And up here somewhere, a negative 0 row. And it's not for the 0, but it's for all of the other values, like negative 0.02 is going to be different than positive 0.02. So just kind of keeping that in mind. The 0 and the negative 0 do match at 50%. So again, your ones and your 10th digit on the left, 100th digit across the top. It's always the area to the left of Z, and it does show you that in a couple of ways. It shows you a sketch highlighting the area to the left of Z. It also does say here, table entry for Z is the probability lying below Z. All right, so that's the table. If you do not have a graphing calculator, then that's definitely the route that you have to go. If you do have a graphing calculator, there are a couple of options for you here. So I'm going to hook up my document camera here so that you can see my calculator. Okay, so I want to pull this up next to the PowerPoint notes so that we can look at maybe these few examples that were here so you can see how it's the same. All right, so with your calculator, if you know your Z-score and you want to find the area under the curve, you have an option under your distribution menu to do that. So this is the equivalent of using Table A. If you hit the second key and then the variables button, this is your distribution menu. The normal CDF option gives you the area under the normal curve when you know your Z-score. So I'm going to select normal CDF. My calculator here gives me a lower and an upper bound. Some calculators don't have that prompt that shows up. If your calculator just says normal CDF at the top with an open parentheses, then you type in your lower bound followed by a comma, followed by an upper bound, followed by a comma, mean followed by a comma, standard deviation followed by a closed parentheses. That being said, your parentheses are here, your comma is here right above the 7. So it's just this input separated by commas. Okay, so if we want to find the area to the left or less than z equals 0.81, this curve here technically extends to negative infinity. I can't type negative infinity in my calculator. So I'm going to trick my calculator into negative infinity by using a number that's so small that it really doesn't make that much of a difference since those tails approach the x-axis. So for my lower bound, I'm going to type in -1 times 10 to the 99th. And you can either type it in here with that exponent notation, or you can just type in negative, but make sure you're using the negative key that's below the 3. -1 times 10 to the 99th using the caret. Either way will work. My upper bound is my z-score, so 0.81. It's the standard normal distribution. So I leave mu as 0, I leave sigma as 1, and I hit paste. And this is what you would see if you didn't have the menu on the previous screen. Your calculator would just say normal CDF. You type in that lower bound, followed by a comma, upper bound, followed by a comma, mu, and sigma. Then I hit enter, and I get the same thing that table A gives me. So this matches what's on that PowerPoint slide. If I want to find between two values, like this example, this is actually pretty nice on the calculator because then you don't have to worry about any subtraction. So if I go back into second and then the distribution menu down to normal CDF, if I want to be between a z-score of -1.25 and 0.81, my lower bound is -1.25, my upper bound is 0.81, mean and standard deviation are 0 and 1. So then that gives me the 0.6854 without having to subtract those areas from the table. One final note with normal CDF is with this Tiger Woods example. So you always should get into the habit of standardizing. So find your z-score and then use that z-score with the table or the calculator because that's required in order to show your work on the AP exam. The AP exam doesn't want to see this normal CDF. They want to see the z-score calculation, the sketched curve with the shaded region, and the probability notation that indicates the direction. But what you can do here, we can take a look once we have z. We're looking for the area between the 0.13 and the 2.63. So we can go back in and do that just like the last example. We've got a lower bound of 0.13, upper bound of 2.63. Mean and standard deviation are 0 and 1 since those are z-scores. That gives me that 0.444 that we saw in the notes. If I had a multiple choice question, or if I just wanted to check my work, I thought maybe I made a mistake somewhere on the way, I can use that normal CDF function with the mean and standard deviation in this Tiger Woods scenario. So I want to know how likely it is that the ball travels between 305 and 325. So I can make my lower bound 305, my upper bound 325, my mean 304, and my standard deviation 8. And then I can hit enter to get here. It's a little bit more precise because it didn't round those z-scores. So I get 0.446 roughly instead. Again, that doesn't constitute showing your work. So just know that that's a way that you can quickly answer multiple choice questions or check your work if it's open-ended, but you are expected to find z and then go from there. One other option that you have is to work backwards. So if I had a problem that said, what is the 80th percentile of Tiger Woods drive distance? If I'm going to use table A gives me all the areas within the table. So if I was looking for the 80th percentile is about 0.8. So if I look here, values of 0.8, I don't have exactly 0.8, but I'm pretty darn close here with 0.7995. The z-score then for that 80th percentile is 0.8, and then if I scroll up to the top, 0.84. So I know that there's a standard score of 0.84 associated with the 80th percentile. I can do the same on the calculator. So on the calculator, if I pull that back up, you have another option on the calculator, still under the distribution menu. It's the inverse norm function, so option 3. Excuse me. The inverse norm is going to be the area to the left is a decimal. So I said 80th percentile, so 0.8, 0 and 1 for mu and sigma. I get my z-score is 0.8416. If you have a color addition calculator, when you pull up inverse norm, it's going to ask you for area, and then some of you have a left, right, center option. So if you have the left, right, center option, you could do it. So like, for example, if I said, what marks the top 20% of his drives? Well, that's top 20% is the same as the bottom 80%. So I'm going to type in 0.8 here since I need the area to the left. But if you have left, right, center, you could type in 0.2 and then just change it to the right. And then it's going to give you that same z-score. So here that z-score is 0.8416, and just to show you how we can find then that drive distance, I will slide that out of the way here in a second. Okay, so the z-score is equal to the x value minus the mean over the standard deviation. So I found the z-score for that 80th percentile was 0.8416. I find that either from the calculator's inverse norm, or I find it from the table and I work backwards. So area on the inside, trace the outside row and column. That's equal to some unknown drive distance minus the mean of his drive distances, which was the 304, over the standard deviation of the drive distances, which was 8. And then I solve for x. So I multiply both sides of the equation by 8, and then I add 304, and that gives me x equals 310, we'll say 0.7 yards. So that would mark the 80th percentile of his drives.